Hello again. My name is Conrad James Calvert, CJC, and this is another episode of CJC versus the LHC. Now, CJC stands for my name, of course, and LHC stands for the Large Hadron Collider. Well, as you know, the Large Hadron Collider is this gigantic particle smashing machine that they built over on the Swiss-French border. It costs between $9 and $10 billion. It's manned and womaned by thousands and thousands of um, diploma-class physicists, as well as um, mechanics and electronic engineers and laborers and students also. I think about 80 countries pitched in to help build it, and they have a network of computers that is spread around the world to help them to interpret all this data that they get from the uh, from the computer, all the data that they collect. So their collision, their particle collision, and the main purpose for them building this machine was to discover the Higgs boson. A boson said to impart mass on energy, and they just claim to have discovered it July the 12th, July the 14th, 2012, because they needed to justify it. So first they needed a project to rally around. They rallied around the Large Hadron Collider, which they was going to build one in the United States, but they couldn't convince Congress that the idea was good enough for them to give them. I think it was only about $3 or $4 million back then for that collider. But over here, not over here, over there in Europe, they were able to convince their governments, and they got the money, they got the collider, and they claim to have found the Higgs boson. But the way that they describe the discovery is so suspect. For one thing, they give you a lot of statistical graphs and they show you bumps on it, and they say that out of 800, get this, 800 trillion collisions, they filter them down to 200 collisions that are possibly Higgs boson, traces of Higgs boson, evidence of Higgs boson. You know, you never really see a Higgs boson. You see that they supposed to disintegrate in such a short time span. As a matter of fact, the time span is so short, I don't even think it's enough time for a particle to create. Now, according to my theory, E equals mc squared equals E equals mc simple. That means that energy equals and turns into matter through circular and or spherical rotation, because c squared is the frequency. The c in the linear direction times c in the 90-degree angular direction, which creates a balance of centrifugal centrifugal forces, allowing energy to attain rest mass in circular and or spherical rotation. And in order for the speed of light to even spin up into a particle, it's going to take at least the time of c squared, because c squared can also be a conversion factor between time too, not just energy and mass, but length, temperature, time, charge, gravity rest mass. You'll find all these things out as we go. And this particle disintegrates so quickly. It just seems to be a conglomerate of matter that never really forms into anything anyway, but a bunch of other particles that it immediately disintegrates in, and they can measure those like photons and quarks and neutrinos, other things like that. But anyway, they say that photons do not have mass, but we know that they do because it's the total electrical effect, and we know that they also uh, are the reason that we have photo cells that create electricity because photons from the sun have mass. They strike these photo cells that cause electricity to run into the wires that generate electricity to power whatever it is you want to power. I mean, these photo cells that people put on their houses and things, they work because of the light that the photons, the light has energy, has momentum, has mass, and they strike these electrons, they strike these cells and create electric flow. So why they say they don't have mass, I don't know. They usually talk about rest mass that they don't have. But mass is defined as uh, the ability to resist a change in the state of motion. Like if I had my cell phone here and I took it, I could say it has mass because I can feel it. It has weight. And I can push it. I can feel it's resisting it. So whether it's still and I try to resist this motion, and it's resisting staying here because it's weighing on my hand. Or if somebody do it at me and hit me, something, well, let me get to this thing. Yeah. Sometimes we just changes the state of motion too. Even though we can't feel it, photo cells can feel it when photo cells are struck by light because they move electrons and generate electricity. And the photoelectric effect that Einstein and Planck and all those guys have worked on, they showed that the higher the energy, the shorter the wavelength, and the higher the frequency, and more particle-like a wave became. And at a certain frequency, a wave becomes a particle. That's why de Broglie gave us the equation that E equals hf, which was the equation that Planck gave us, equals E equals mc squared, which was an equation that Einstein gave us for matter and electrons. He put them together. De Broglie put them together. He said, well, the photon equation E equals hf equals E equals mc squared. The matter equation at a certain level, at the level of the electron and the positron, because they're really the same thing. A photon turns into an electron at a high enough frequency. C squared is the frequency. See? You don't need a Higgs field. All you need is a field that's already out there. They used to call it the ether field. And when they had, when they couldn't detect the ether field with something called the Michelson-Morley experiment, scientists gave up on it and say, well, there must not be an ether field or we can't find it. But then when general relativity came around, and when and they tried to find an ether field by shooting beams of light in 290-degree angular directions on Earth and seeing which one, if they came back, one came back before the other, because if one was going in the direction of the Earth, it would go either go faster or slower or something, and the one going to the side, I think they said would beat it. You know, you can look at demonstrations on the web and they'll show you. But anyway, it was supposed to create an interference pattern and show which direction the Earth was moving in through the ether. But it always showed up that the speed of light was the same in all directions. So people say, well, there must not be an ether. But that wasn't true because they were just too close to the Earth, and the Earth kind of like binds the space around it. curve the space around it. But when you look out in the more space, the global space, the bigger space, you'll see, just like Hubble did, that the universe is expanding, and the Doppler effect of the light coming the moving um, from the moving galaxy become red and redder. Like light moving in the direction away from you becomes redder, and light moving towards you becomes bluer. It's like the speed of light is constant in the linear direction. But if something has more and more speed, like a car, and it's shining a light, or a flashlight, or light is shining off of it, just because it can't go no further in this direction, that doesn't mean that the light is not moving faster. The light doesn't move fast in this direction, it moves fast in this direction. The frequency gets higher. When light reflects off a faster moving object, the frequency gets faster. So it's like the speed of the object is added to the frequency. So that's how light takes on the speed of the object reflecting or emitting it through frequency, not by adding to it in the linear direction. And Einstein developed this E equals mc squared in part by measuring the light emitted from an object in motion. He measured the light in the direction of motion and in the direction away from motion. It found out that light has energy of, I think he called it L equals 1 divided by the square root of 1 take away b squared divided by c squared. It was some relativistic equation, but he could have simplified it and just said E equals m divided by c squared. He also noticed that if a mass emits light, its mass, if mass emits light, its mass would diminish by uh, E divided by c squared. That a mass emitting light would get lighter. And he concluded from this that E equals mc squared. In other words, that things were made up of energy, period. And another thing that he had to help him along, uh, does the inertia of a body depend on its energy content? That's the name of the paper if you want to read that. That describes what I just said. Does the inertia of a body depend on its energy content? That's the paper. Okay, and another thing that helped him discover E equals mc squared. Back in France, um, they were debating Newton's idea of momentum and Leibniz's idea. Newton had said, now this came from Einstein's big idea, a documentary that they had on Nova a couple of years ago. It's still on the web. You can look that up too. Punch that in on YouTube and you can get the whole documentary. Well, this is the gist of the story. Newton claimed that the force, which they call energy and force were the same thing back then, and they really still are. We're going to keep it like that for simplicity. That the force with which an object connects with another can be simply described by its mass times its velocity. Saying that if you drop something and it hits something, the force with which it hits that thing can be described by its mass times its velocity. So that meant if you dropped it and the velocity was twice that of the first, say you dropped it the first time and it went in some clay. You dropped the ball in there and it went in some clay 1 inch. If you dropped it to a point where it traveled twice as fast and it went into that clay, according to Newton, it would only went in there 2 inches. If it's got one speed, it'll go in 1 inch. If it's got twice that speed, it'll go in 2 inches. But lightning said, no, you have to square that speed. The force with which an object it contacts another is equal to its mass times its velocity squared. So if you take an object and drop it into clay and it goes in 1 inch, and you double the speed and drop it into that same clay, it won't travel 2 inches. It will travel 2 inches squared. It will travel 4 inches. And he was right. They did the experiments and found out he was right. And somehow Einstein and also Lightning also suggested that objects had inner spirit and that explosions were the release of these inner spirits. So he was like even ahead of Einstein when it came to blowing things up, uh, realizing that things had energy in it. He just didn't get to the nuclear level. He was more on the chemical level of blowing things up. But he said, yeah, that comes from the inner energy of things. But anyway, Einstein took it further and said, well, not only does the force of an object depend on its mass times its velocity squared, the whole thing is made up of its its energy, which is light. Its mass times the velocity squared, which is the speed of light squared. It's made up of the highest velocity. Its mass times the highest velocity squared, which is the speed of light squared. So you get what um, Leibniz said, force F equals mv squared. These days, they would say this is dimensionally uh, incorrect for reasons that I can dispute because on the quantum level, dimensional analysis breaks down, and I'll show you that on another video. But you can see how when I'm saying that if you drop an object of clay, a lead ball into clay and it travels 1 inch, and then you drop it twice as fast and it travels 4 inch, the force of that dropping a clay ball is equals to its mass times its velocity squared. And you can put that in letters F equals mv squared. And I don't care who disputes it. And you can change the F to E and keep the M and change velocity to C. And F equals mv squared becomes E equals mc squared. And the force that it takes for an object to drop and deliver an impact on another object is equal to its mass times its velocity squared, and the whole thing, inside and out, even its rest mass, is equal to its mass times some velocity, internal velocity, the speed of light squared. And how does that happen? Well, let's get a view of it happening on the quantum level. The speed of light squared is the speed of light in this direction, and as the frequency gets higher and higher, the waves get shorter and shorter, and more particle-like. Instead of being long, they become shorter and shorter, and more particle-like. And at some point, the speed of light in this direction equals the speed of light in that direction, and it creates, say you got a square. Am I got the square? Okay, a square. It'll create, I can't even do this on the thing, a square. Okay. It'll create like a 90-degree arc. That wave and make a circle. And if the amplitude is constant, it will make some circles, which will constitute the standing spherical wave. So you get binding energies and standing spherical waves from the speed of light squared. The speed of light squared, it doesn't have to go through Higgs field. We don't need to make up a Higgs field. The ether, the space itself, whatever you want to call it, 0 point field up, they got all these names for it. Already does that. it already compresses light against it. Just like I said, if you were to take a car and shine a light from it as it moves, the, the speed of light would still be the same, but the frequency would rise because it's getting compressed against the light current. And if you could get that frequency to reach c squared, it will turn into matter. So the force or the energy with which matter is made of is equal to a mass times velocity squared, which is the speed of light squared. Mass times the speed of light squared. Energy equals in terms of mass through the speed of light squared. The speed of light squared is what turns energy raised into mass, and it also unravel the energy so it can turn back into energy. Unravel the mass so it can turn back into energy. So, there you are. Thanks for listening.